Hello, and welcome back to One a Day to Get 5 May for AP Precalculus. This is episode 11, and today we're going to be doing another problem from Unit 3, which I think that Unit 3 is probably the most tricky, so it's probably good to do some extra practice in that unit. So here's the problem. If the terminal side of angle A in standard position is in quadrant 1, and cosine of A is equal to 5/3, what is the value of sine A times tangent of A? Okay, so how about you try the problem, pause the video, and then just come back and review the answer. Alright, so hoping you pause the video. Basically, let's just kind of draw a nice little sketch of this, right? So this is our x-axis, this is our y-axis. Let's draw a nice little unit circle. That's really bad, but it doesn't matter. So this is quadrant 1, this is quadrant 2, this is quadrant 3, and that's quadrant 4. So as you know, if you can notice, the first quadrant is the upper right, and then they just kind of go counterclockwise, right? So we know that the terminal side of angle A is in standard position, and in quadrant 1, right? So we're given that cosine of A is equal to 5/3, and that means that the x-coordinate of where it passes through the circle is 5/3, which means it's to the right of the y-axis, right? So it's going to be like somewhere over here, right? It's going to be the x-coordinate, which means that it could be either one of those points, unless if we weren't given that was already in quadrant 1, right? So we know it's not this one. So basically, this is what our angle is going to look like, right? This is cosine A, and sine A is the y-coordinate, and then this is 5/13, and we don't know what sine is, right? And we're going to want to know what sine is, and we're going to want to know what tangent is, so we can evaluate sine times tangent, right? And what we're going to use for that is the Pythagorean identity, or one of them, because there are 3. So sine squared of A plus cosine squared of A is equal to 1. So let's plug in cosine of A equals 5/3, right? And let's do a little bit of simplifying. 5 squared is 25 over 9. Oh wait, I'm sorry, that's 13. I apologize. And 13 squared is 169. Yeah. Okay. So that's what we get. Let's subtract 25, 1/69 from both sides. Those cancel. We get sine squared A is equal to, well, this 1 right here, that's 1/69 over 169. So we want to find 169 minus 25, that's 144. So sine squared A is 144 over 169. And let's take the square root of both sides. And what we get, what we get is sine of A is plus or minus, because it's squared and then we're taking the square root, we have to do that, 12/13, right? But we know that the terminal side of the angle has to be in quadrant 1, which means that cosine is positive, right, because it's to the right of the y-axis, and sine is positive because it's above the x-axis. So we can just ignore that minus, right? So that's why it's very useful that it tells us that it is in quadrant 1, and problems will often do that, because otherwise there would be two answers to this if it didn't give us that. Okay, so sine of A is 12/13. Now, to get tangent of A, we're just going to use tangent of A is equal to sine of A over cosine of A, right? And that's going to be equal to 12/13 divided by 5/13. Let's multiply the numerator and denominator by 13 to cancel out that 13 in both of their denominators. We get 12/5, right? Or I don't need to box that, but we want to know what sine A times tangent of A. So sine of A times tangent of A is equal to 12/13 times 12/5. And so that's 144 up here. And let me see if I can do the math. So that'd be 50 plus 15. So I think 65. Yeah, 65. So our answer is 144 over 65, which is answer choice A. So I hope that you enjoyed the video, and I hope that you found it helpful, and I hope that the rest of your day goes well.